Today we'll be exploring a few new tools on CATIA. First, let's keep the product open and rename it as our example part. Then we insert the part and we also give it a new name. Now we are ready to start using Sketch Tracer as a workbench to bring an image in. First, make sure that we select the front view from the View toolbar. Now, let's open an image file, and when we do, we might get a wrong view mode error. We're just going to change the view mode to shading with material. Check your units at this point. Enable millimeters as default if you haven't yet. We're going to set up our main axis at the start of the image, the tail at the exit number 9, and we set up the main dimension to be 10,000 millimeters. Now we are ready to edit the part itself. We switch over the part on the spec tree and we select Sketcher for this particular plane, and we are ready to create the initial profile. Start with an axis that lines up with the axis on the image. And we start creating the profile using our profile tool. For the straight edges, we simply start at the axis and we more or less trace the image that we are interested in. For the curved lines, we're going to use the spline tool. Notice that as many points as needed would help us have a smoother transition from one to the next. If we place too many spline points, simply select the ones you don't want and remove them. Now we can close our profile and adjust any spline elements one by one. If we have additional coincidences such as this, we can simply delete them as we adjust our profile. Now we can exit and we can use the shaft command to revolve it around the axis. Let's create a hole at the center of the hub. We're going to use the origin as reference because we started with the image at the origin. Constrain your diameter to 500 millimeters and then exit and pocket the profile to 4,500 millimeters. We are now ready to start working on the blades. First, let's insert an offset plane from the XY plane at 1300 millimeters. And let's hide the image from view. We can now start creating the first set of blades on the XY plane. Draw one line and constrain it to the following length. And align it with the front edge of the hub with a coincidence command. Now exit Sketcher and go to the offset plane where we're going to draw the leading edge. Constrain the leading edge as shown in the image. Now exit Sketcher, and we're going to switch workbenches to Generative Shape Design, or GSD, to create a surface that represents a single blade. Now in GSD, select Multi-Section Surface and select the two sketches representing the beginning and end of the blade. Click OK to accept once they're both been selected. And we're going to eliminate the portion of the blade that's inside the hole. So we split the surface, where the element to cut is the surface we just created, and the cutting element is the inside of the hole. Now we exit by accepting the split definition, but make sure that you are on the correct side of it. Back to Part Design, we assign a surface thickness to it. In this case, 5 millimeters either way, and click OK. Now, hide the elements that are unnecessarily being displayed, and let's pattern the blade. We want 50 of them, evenly spaced around the hub. And we have the first set of blades. Now we're going to repeat the same process with the next two sets of blades, but please follow the updated images with the constraints that you need to put in place. Do not forget to select the offset plane as your leading edge plane. Remember that if a constraint gets on the way of the line you need to select, like this in this case, simply move the constraint down to be able to constrain to the points you want. Now that you have these two sketches, repeat the steps from the GSD workbench and create the surfaces of the new blade. Add thicknesses to it from Part Design and apply a circular pattern. Let's try this one more time with the last set of blades. Again, place the base of the blade and constrain to the edge of the hub. Then create the leading edge at the offset plane and constrain as shown. Let's repeat the steps one more time. Go to GSD, use multi-section surface to model the blade, split the blade with the center hub, go back to Part Design and add thickness to it, and replicate the pattern around the hub. Now let's add additional elements by projecting some of the existing part onto a new sketch. As always, let's create my axis, and we can constrain it to the center of the hub to make sure that it aligns. And now let's use intersect 3D elements to trace some portions of the part onto my sketch. make sure the additional elements on one side of the axis become reference elements. And let's complete the profile we want using the profile tool. If the elements are still drawn as reference, you can turn it off on Sketch Tools. We are not fully constraining this sketch. This is just an approximate model anyway. We can project a visible edge, but in this case we're going to use the Project 3D option and complete our profile. Be sure to trim any additional lines that are not part of your final profile. Let's add an additional profile that aligns with this one. We're just going to use the profile tool for this. Exit, use the shaft command, and let's move on to creating the nose cone. For the nose cone, we again go to the main plane of our view, the YZ. We are going to add an axis line and project the edge of the hub. Remember that the axis line needs to coincide with the hub so that it aligns its center. And trim anything that's on the opposing side of the axis line. For the nose cone, we're going to use the spline command again, creating as many points as necessary, and adjust them until we're satisfied with the result. Exit Workbench and apply the shaft command once again. To create the nacelle, we once again are going to trace from our original image onto a new profile. Remember to coincide the axis to the hub once again. Use the profile tool to sketch the nacelle on one side of the axis. Constrain the front to 100 millimeters. You may have to zoom in to get a proper view. Similarly, we will do the same at stage 9, except we're going to constrain to 290 millimeters. Again, use the shaft command to create the nacelle. We can now adjust the nacelle's transparency. Just right click on the element, in this case the shaft, go to Graphic, under Properties, and adjust the transparency to 150 or any number you desired. Click OK and press the isometric view button to see our engine. If you wish to rotate the engine 90 degrees, remember you can use the rotate definition command. Right click on the axis box and select the axis about which you want to rotate. In my case is the axis by 90 degrees. Press OK and you can fit the engine into the screen and see the new isometric. Because we use sketch tracer, we can edit the dimension. We can scale the engine up or down by adjusting the value that we initially set up to scale our image. And we can revert back to the original scale of our engine model.